To understand chlorine and chloramine control, let's start with a simple line that shows measured chlorine levels and the amount of chlorine that is added to the water. When you are dosing and measuring chlorine, you overcome your chlorine demand, and as a result, you see chlorine residual building in the graph. To explain this concept, we will use a closed system, a bucket of water without the presence of ammonia. As we add chlorine to the water, it is used up at first as it reacts with the existing matter in the water, for example, bacteria, organics, etc. So we do not measure much, if any, chlorine. But eventually the chlorine added has exceeded the demand and we measure more chlorine, as is indicated by the graph in the upper right-hand corner of your screen. When you chloraminate, you add chlorine to water with existing ammonia, or dose both chlorine and ammonia together, or you can add ammonia to water that has already been chlorinated in the treatment plant or another utility. In this example, let's pretend we are adding chlorine to water that already has ammonia. When ammonia is added to chloraminating systems or is present in the system, our graph changes, pushing up the amount of matter the chlorine has to bond with initially. This creates what is known as the chloramination curve. You are trying to create monochloramine. The ammonia drops a hydrogen atom and the chlorine takes its place. When you have effectively bonded one chlorine molecule with each ammonia, you have achieved the ideal state of monochloramine disinfectant. If you continue to dose chlorine past this state, you begin to experience di- and finally trichloramination. These states are not ideal. It causes your chlorine residual to drop radically, although you are adding more chlorine. You will experience taste and odor issues when you are in this zone, and your disinfecting power is drastically cut. Once you pass the point where you have fully bonded all the nitrogen from the ammonia with the chlorine, you return to the original chlorine curve, where for every part of chlorine you dose, you will see 1 part of chlorine residual. Let's take a moment to make an important differentiation. What is the difference between free and total chlorine? Free chlorine refers to both hypochlorous acid and the hypochlorite ion, or bleach, and is the form of chemical commonly added to water systems for disinfection. When ammonia is also present, monochloramine, dichloramine, and trichloramine will form, as we saw. Chloramines are also known as combined chlorine. Total chlorine is the sum of free chlorine and combined chlorine. The level of total chlorine will always be higher than or equal to the level of free chlorine. So how do you know where your utility's water lies on this chart? Some simple measurements can tell you. For instance, in Zone 1 you will see total chlorine and a presence of free ammonia. In Zone 2 you will see total chlorine, monochloramine, total ammonia, but no free ammonia. In Zone 3, you will see no ammonia and only chlorine, and your free and total chlorine values should be very similar or match. If you know the key parameters to look for in each section, it is easy to determine where you are on the chloramination curve. So does this change if your utility adds ammonia to water that has already been chlorinated, as many do? The concepts all stay the same. You just move backwards along the line. Ammonia is added to the chlorinated water just prior to entrance into the distribution system. The dose is increased until a small trace of free ammonia is detected, ensuring you are in Zone 1 and maximum monochloramine residual has been reached. To determine where on the chloramination or chlorine curve your utility is, or for more information, please visit hoc.com/chloramination.